In this lesson, we're going to learn about limiting and excess reagents. So when I have two or more things reacting, in reality, I often will measure out each of my reactants. If I have oxygen as one of my reactants and I'm just using oxygen from the air, then I'm going to have plenty of quantities of that. So in reality, we will often have a certain amount of each reactant, and we will not always have them in the mole-to-mole ratios that we need them in, which means that one of the reactants will get fully used up and one we will have leftovers of. So an analogy for this, if I am making s'mores, for every s'more that I make, I need one marshmallow, so same amount. For every s'more, I need 4 chocolate chips, so I need 4 times as many chocolate chips as s'mores I'm making, and for graham crackers, I need twice as many graham crackers as s'mores. So if I want to make 2 s'mores, I would need 2 marshmallows, 8 chocolate chips, and 4 graham crackers. If I'm making 25 s'mores, 25 marshmallows, 100 chocolate chips, and 50 graham crackers. 1,000 s'mores, I would need 1,000 marshmallows, 4,000 chocolate chips, and 2,000 graham crackers. And if I'm making 1 mole of s'mores, I would have 1 mole of marshmallows, 4 moles of chocolate chips, and 2 moles of graham crackers. So if I don't have those amounts, so the amounts we looked at before were the exact ratios we would need to make a certain amount of s'mores. So here, I don't have those in the same ratio. So for every 1 marshmallow, I need 4 chocolate chips and 2 graham crackers. So my next marshmallow, another 4 and another 2. So in this case, I'm left with 2 graham crackers and 4 chocolate chips. So my marshmallows here would be limiting how many s'mores I can make. So that's called my limiting reagent or limiting reactant. And the graham crackers and chocolate chips I have in excess. So I have 4 chocolate chips that aren't going to get used up, and I have 2 graham crackers that aren't going to get used up. So those are called my excess reactants or excess reagents. So I have 2 graham crackers and 4 chocolate chips in excess. So let's take a look at how this applies to chemistry. So Haber process again, nitrogen and hydrogen combine to make ammonia in the ratio of 1 mole of nitrogen for every 3 moles of hydrogen to create 2 moles of ammonia. So how much nitrogen would be made if 2 moles of nitrogen react with 3 moles of hydrogen? So for every 3 moles of hydrogen, I'm going to use up 1 mole of nitrogen. So then I have 1 mole left over there for the 3 moles that got used up. And every 3 moles is going to make 2 moles of hydrogen. So 2 moles of nitrogen will be made. 1 mole of nitrogen was used up. So how many are left over? So there's 1 mole of nitrogen left over. So we can use the stoic calculation skills that we learned in the last lesson for 3 different types of limiting reactant calculation. So we can figure out which of the reactants is going to run out first. So that's our limiting reactant. We can figure out how much product is going to be made from the limiting reactant we have. And we can also determine how much of the excess reactant is left over. So if I have copper and sulfur combining to make copper sulfide, this is copper 1 sulfide, what's the limiting reactant if I have 82 grams of copper reacting with 25 grams of sulfur? What's the maximum amount of copper 1 sulfide that can be formed? And how much of the excess reactant do we have? So the first one, what's the limiting reactant when 82 grams of copper react with 25 grams of sulfur? So we can start with either reactant here. We can start with 82 grams of copper or with 25 grams of sulfur. So we learned in our stoic lesson how to take a certain mass of one reactant and determine what mass of another reactant we would need. So we can pick either one here. I'm going to start with 82 grams of copper. So I'm going to take 82 grams of copper. Using its molar mass, I'm going to convert to how many moles that is. Then using my coefficients from the balanced equation, I'm going to use my mole to mole ratio of copper to sulfur to determine how many moles of sulfur would be needed for that, and then my molar mass of sulfur to determine what mass of sulfur I would need. So that will give me the mass of sulfur I would need for 82 grams of copper. And then we'll see 25 grams of sulfur is what I actually have. So we'll see if the amount of sulfur that's made is more or less than 25. So molar mass of copper is 63.55 grams per 1 mole. So remember, we do that so that the grams of copper can cancel out, and that will leave me with a number of moles of copper. I'm then going to use my mole to mole ratio from the balanced equation. So for every 2 moles of copper, I need 1 mole of sulfur. So that will get me to how many moles of sulfur I need for 82 grams of copper. Then I'm going to use the molar mass of sulfur. So for every mole of sulfur, the mass is 32.07 grams, and then that will tell me what mass of sulfur I need for 82 grams of copper. When I calculate that, I get 20.7 grams of sulfur. And so do I have 20.7 grams of sulfur? I do. I have more than that. And so what that means is once I've gone through the 82 grams of copper, 20.7 grams of sulfur will have been used up, which means I'm going to have some left over. So that means that copper is my limiting reactant. So that's what I need to use in my next question, where I have to calculate the amount of copper sulfide that can form. So I have to start with what limits me. I can't use my 25 grams of sulfur to determine my product because I won't have enough copper to react with 25 grams. So the sulfur is going to be in excess, copper is limiting. So that's what I need to use. So I'm going to start with my 82 grams of copper again, use the molar mass to calculate how many moles that is, use my mole to mole ratio. So 2 moles of copper for every mole of copper sulfide, and then I need my molar mass of copper sulfide. So from the periodic table, I would need to calculate 2 of the atomic mass of copper plus the atomic mass of sulfur. And so for 1 mole of copper 1 sulfide, that is 159.17 grams of copper 1 sulfide. So my grams of copper cancel, my moles of copper cancel, moles of copper sulfate cancel, and then I'm left with my mass of copper sulfide. So the maximum amount of copper 1 sulfide that can be created from the 82 grams of copper and 25 grams of sulfur is 103 grams. So then how much of the other reactant is wasted? So the excess reactant here was sulfur. So I started with 82 grams of copper and 25 grams of sulfur. The entire amount of copper gets used up. We calculated already in part A that for 82 grams of copper, 20.7 grams is used up. So that means that I started with 25 grams, 20.7 got used up, which means that 4.3 grams of sulfur is in excess. Next question, hydrogen gas can be produced in the lab by the reaction of magnesium metal with hydrochloric acid. So the balanced equation is for every 1 mole of magnesium, 2 moles of hydrochloric acid are needed, and 1 mole of magnesium chloride and 1 mole of hydrogen are produced. So what's the limiting reactant if 6 grams of hydrochloric acid react with 5 grams of magnesium? What's the maximum amount of hydrogen that can be formed? And how much of the other reactant is in excess? So once again, for my limiting reactant, I can either start with the 6 grams of hydrochloric acid or the 5 grams of magnesium. So those are my 2 reactants. the amounts that I actually have, I can pick either one to determine how much of the other I would need. So I'm going to start here with 5 grams of magnesium using its molar mass, so 24.31 grams per mole. Then the mole to mole ratio between magnesium and hydrochloric acid. So magnesium is going to go in the denominator so that that can cancel. So I have 1 mole of magnesium in my balanced equation for every 2 moles of hydrochloric acid. Then I need my molar mass of hydrochloric acid, so 1 atom of hydrogen and 1 atom of chlorine. So for 1 mole, hydrochloric acid has a mass of 36.46 grams. So my moles of hydrochloric acid cancel here, moles of magnesium, grams of magnesium. So I'm left in grams of hydrochloric acid. So remember, everything that is in the numerator is a multiplication, everything in the denominator is a division. Anything that is 1, we can ignore because multiplication and division by 1 doesn't alter our answer. So 5 grams, or 5 divided by 24.31 times 2 times 36.46, and that gives us 15 grams of hydrochloric acid. Now, I do not have 15 grams of hydrochloric acid, which means all of the magnesium would not get used up. So that means in this question, the starting point that I used, that is my excess, and hydrochloric acid is my limiting. So when I calculate the amount of hydrogen that's created, I'm going to need to use 6 grams of hydrochloric acid as my starting point. So for the maximum amount of hydrogen, starting with the 6 grams of hydrochloric acid, converting that with its molar mass to its number of moles, then using the mole to mole ratio from my balanced equation. So moles of hydrochloric acid are 2, and that's going to go on the bottom so that I can cancel my moles of hydrochloric acid. Hydrogen is what I'm looking for, and there's 1 mole of hydrogen, and then my molar mass for hydrogen. So what's my mass per 1 mole? And 2 atoms of hydrogen, so 2.02 grams. So then my answer here will be in grams of hydrogen. So I have 6 divided by 36.46 divided by 2 times 2.02, and that gives me 0.164 grams of hydrogen. So then my next question was, how much of the excess reagent do we have? So here I haven't actually figured out how much of the excess gets used up, because the first calculation I did told me that I actually didn't have enough hydrochloric acid for the amount of magnesium I had, which means that I have to go through another step. So calculating for the hydrochloric acid how much magnesium gets used. So I originally had calculated for magnesium how much hydrochloric acid would I need, and I didn't have enough. So once again, molar mass to convert to number of moles of hydrochloric acid. Then from the balanced equation, my mole to mole ratio, so 2 moles of hydrochloric acid for every mole of magnesium, and then using magnesium's molar mass to get to the mass of magnesium that would get used up for 6 grams of hydrochloric acid. And that gives me 1.997 grams of magnesium gets used up. So I had started with 5 grams of magnesium, 1.997 grams gets used up, which means 3.003 grams of magnesium are in excess at the end.